Hello friends, welcome again. Today we'll be solving a question related to network analysis and synthesis. And the question is, we are given a circuit here and we are asked to find IL of t for t more than 0. Okay, and we are given the current IL of t at 5 amps at t equal to 0. Okay, so how to proceed for this question? So first of all, let us apply KCL across this node. I name it as A. Okay, so the current entering will be equal to the current leaving. Okay, so let us call this current as Ix, which is leaving the node A. Okay, and flowing across the 20 ohm resistor. So we can write it as 0.25 IL of t is going to be equal to Ix plus IL of t. Okay, so from here, if you calculate Ix of t, you get 0.25 IL of t minus IL of t. Okay, so this, if you write now, it comes out to be minus 0.75 IL of t. Okay, so this is the current which is flowing now across the 20 ohm resistor. Okay, so now one task is done. We have found the Ix value. Now let us apply KVL across the loop. Which loop? This loop which I am highlighting now. So now I know this current Ix. Okay, the Ix already we have calculated. This is minus 0.75 of IL of t. Okay, now this is already done. Now let us calculate. Let us apply KVL. Okay, so uh, from KVL we get 20 Ix is equal to 10 into IL. Okay, I'm dropping the t IL of t because it's a function of t. Okay, so L dIL over dt. Now what I can do is I can replace Ix with the value which I found here. Okay, so it is 20 into 0.75. Okay, this minus sign also included here. Okay, IL is equal to 10 IL plus LDIL over dt. Now what you can do here is you can take all the IL terms this side, and here you get minus 15 IL minus 10 IL is equal to L DIL over dt. Okay, so now again if I write it, it becomes minus 25 IL is equal to L DIL over dt. Okay, now proceeding further, putting the value of L is equal to half. So what you get? Half DIL over dt is equal to minus 25 IL. Okay, or DIL over dt is equal to minus 50 IL. Okay, so this is what you get. Now we have the expression of IL. Okay, now once we have the expression, we have a differential equation of IL. Now this is a very simple differential equation which can be solved easily. So let us proceed and solve this differential equation. So again I will write DIL over dt is equal to minus 50 IL. Okay, so my DIL is equal to minus 50 IL into dt. Okay, now what I can do, I can put this IL on the other side. So I get DIL over IL is equal to minus 50t. Now I can integrate both the sides. Okay, so when I integrate both the sides, this is a simple integration. This is log of IL. So log of IL plus log of C, because a constant term will come, so I can write it also as log of C because it's a constant, plus is equal to minus 50 t. Okay, 50 t. Okay, so sorry, this is dt. So now it is 50 t. So now what I can do, I can use the property of log, and it will be IL into C is equal to minus 50 t. Okay, so now I can calculate IL. I can take anti-log both sides, and I can calculate IL into C is equal to e power minus 50t, e power minus 50t. Okay, or I can write IL is equal to 1. I can write IL is equal to 1 by C into e power minus 50t. Okay, now the expression of IL is with me. Only thing which is left is the finding the value of C, which can be found with the help of initial condition, which is IL of t equal to 5 amps at t equal to 0. So substituting that, I get IL at 0, okay, is equal to 5, which is equal to 1 by C into e power 0, which is equal to 1. So from here C is equal to 1 by 5. Okay, now our C is also calculated. Now I can put this value here. So I get IL is equal to 5 e power minus 50t. Okay, so now I have the expression for IL of t. Okay, I can say, which is 5 e ki power minus 50t. Okay, so here this is how you have to proceed for this question. Okay, just be careful about the signs here. Okay, whenever you are taking certain signs, hmm, proceed with the same signs so that you get the correct answer. Okay, mathematics will take care. Okay, so thanks for watching.